Hello students, today we will discuss about the differential equation. As you know that this is one of the fantastic topic in the mathematics. So the prerequisite for this topic is that if you want to study the differential equation, we should have the knowledge of differentiation as well as integration. So today we will start differential equation. So let's start the what is the definition of the differential equation. So differential equation.
What is the mean by
Friends, any equation which
What
where
is the mean by equation?
yes, equation which contains independent variable, dependent variable, and the derivative of the dependent variable with respect to the independent variable. This type of equation is called the differential equation.
No, bro.
For example,
I want to ask, what is the equation? What you mean by equation, not
yes,
differential equation?
yes. First, it's okay. We can understand equation.
equals to 0.
Anything which is written in form of fx equal to 0, that is the equation. For example, if you are going to write something x power of 4 x square plus 1, this is a polynomial. But if you are putting something equal to 0 or equal to some number, you can say some constant, then this is a equation. But here we are not talking about the equation. I personally feel that if you are going to discuss about the differential equation, you are having the knowledge of equation. So anything which is written in this form fx is equal to 0 or fx is equal to constant, there will be something equal to that fx. So this is just the
What represent equation?
equation. Equations may represent line, represent the curve, but mainly equation is the polynomial. So, but here we are talking about the differential equation. It contains the differentiation of the dependent variable with respect to the independent variable. For example, if I am going to say that dy by dx plus py is equal to q. Here we have p, where p and q is the function of the x. So here we can say that this is a differential equation because it's containing the dy by dx, y, and p and q in the form of x. We can have function of x or we can have any constant. So this is a differential equation. It may be possible that some of you may come and ask, sir, what about this one? Plus p dy by dx plus qy plus r. This is also a type of differential equation because there is only difference of the order. This is the second order line, but here this is the only there is only dy by dx, but this is double derivative. So there may be any type of
What
derivative.
is mean by order of differential?
Definitely we will discuss all these things, but first we should try to discuss about the differential equation, and after this I will discuss order and degree and everything. So this is the differential equation. So these are the concepts which I know, and I feel that you are sure about the definition of the differential equation. And as you know that you asked about the order and degree, which is my next definition. We will also discuss about the order and degree. So let's discuss about the order of the differential equation. What is the order? Order is the number which is present, which represent the highest order derivative, which present in that
ये रखा है
particular
face wash
differential
लोग
equation.
face wash
For example, you can take this differential equation. So my definition of order is saying that highest order derivative which are present in that differential equation, that is the order. So where in this differential equation, higher order derivative is the this one. This first because this is the second order, this is the first, so highest order, so this will be 2. So order will be for this differential equation is equal to 2. So you can say order is equal to 2.
Okay. I have an example.
Yes.
Right.
Yes, you can tell me.
Due to y over dx square
D to y over
dx square
dx square
plus
plus
due to x square due to y square
d to
x square. Sorry.
x square
Sorry, due to x by dy square
dy square
plus qy
ये क्या कर रहे तुम
plus qy
equal to
is
p.
equal to
p.
p. Okay.
This is differential equation or not?
नहीं partial differential equation
Huh?
This is differential equation or not?
This is differential equation or not. Actually, what we are doing, we are in equation or differential equations. In definition, we studied that there must be derivative of one. This is a partial differential equation.
Maybe, maybe not.
Maybe or
Because
maybe not.
why? Because
Because this is the difference with respect to y, no?
when you differentiate, it should be in the function of x's, right? But here x.
Okay. Right. Another example.
Yes.
Dy over dx
dy
over
over dx
plus dx over dy
plus dx
dy
over dy is equal to
plus qy plus equal to p.
p.
What about this?
What about this? So I think we can change this because this can be written in the form of 1 upon dy by dx, and then we can multiply this. I think this will be order 1 because this is the maximum order is 1.
I'm not asking about order. I am asking this differential equation or not.
This is differential equation or not. If you dy by dx, q y dy by dx, this is differential equation.
And first one is
First one, I think this can't be arranged in this form. I think so. I'm not sure about this one, but I am sure about this. This is differential equation. But what about this?
this is also a part of differential equation.
Yes, that
Your
is
topic
part
is
of-
also differential
that
equation.
is
Why
a-
you not
yes.
telling about this?
I think that this is also part of differential equation. But how it can be possible? Yes, you are also right. You are right. So this is differential equation.
Yes,
Order 2.
order 2, but we cannot solve.
We cannot solve.
Yes.
Okay. This is differential equation, but we cannot solve. Okay. No way. Yeah. I got it. So let's discuss about the order. So these are some examples that which contain order 2. So we can take another example like d q y dx square plus p d square y upon dx square plus you can say c or you can take anything 0. Now we want to discuss about the order of this differential equation. So what can be the order? Actually, highest order derivative is the 3 here. 3. So order in this case will be 3.
That is partial differential equation.
Can't be.
Previous one,
2. Not partial differentiation.
not this I'm saying. Previous one, previous example. Sorry. dy by dx and dx by dy. Those are not
That
partial.
was not partial differentiation. That was the ordered differential equation. So it's very possible that some of you may ask this type of question that the
You see ones like
power 1 by 2
3
is equal
ux
to
plus 5y. 5
dy
y
by
minus ux.
dx.
If you remove this
No,
term
whole
0
square.
now.
Here
it's
you
very possible that
independent variable and x or y is independent variable.
it's very
Here
possible that you can ask order in this case.
y is
So,
independent variable.
order-
Independent variable.
So the order will be in this case is will be 2 because we have to only check the highest order derivative which are present in the differential equation. So order will be 2. I am sure that you
Let's go
understand the
forward to
definition.
degree.
Huh?
Let's go forward to degree.
Degree, no?
Okay.
Yes. I think you are sure about the order of the differential equations, and these examples are sufficient to explain the order of any differential equation. And I am sure that if you solve the questions in NCERT books, that will be sufficient amount of questions are given, and if you try to solve, then those questions are very easy and you can solve. So now we are going to discuss about the degree, which is second term involved in the differential equation. So degree. So we want to discuss about the degree. Degree is the power which is present in the highest order derivative. What is the mean? Degree is the power which is present in the highest order derivative, and that power must be a integer number. For example, let's discuss about this one. If I am going to ask you that, tell me the degree of this differential equation. So what you have to check? You have to just first check that what is the highest order derivative of that differential equation. Highest order derivative term is this first one, d cube y upon dx cube. And now I have to check that what is the power of this term. So power will be 1, not 3. This is not power. 1 is the power. So degree will be 1 in this case.
Okay, okay. Write an example.
Let's discuss about this one. That what is the highest order in this case? 2. But and what is the power? Power is the 1 by 2. And I have told you in the definition that the power and highest order derivative must be integer. If it is not, then we have to make that integer. How can we possible? We can square both sides. If you square this both sides, then this will be d square y upon d square power 1 and this will be power 4. So in this case, and then when we just solve, then this will be degree 1. So these are some things that we have to remember. Let's discuss some good example in a degree. Actually,
I have an example.
yes, please tell me.
Due to y over dx square
d2
y
y over dx square
plus
plus
e to the power dy over dx.
p
E to the power.
e
Yes.
e to the power
Dy over dx.
dy over
Dx.
dx
Plus
plus
y equal to 0.
y is equal to
0. What is the degree of
degree of
this?
this. But if you discuss about the order, then order will be 2. It's a very obvious thing, na?
Okay.
But you want to discuss about the degree of the differential equation. We have to remember, students, we have to remember one thing. When we are going to discuss about the degree, we have to remember that one thing: dy by dx must be free. Our differential equation must be polynomial in terms of dy by dx. But if you see this differential
But in
equation
your definition, you are not mentioned.
in when we find out degree, we have to remember this. If you say I can write down
You
here.
have to mention in your
Yes,
definition.
you can write down here. When we are going to find out degree of any differential equation, that differential equation must be a polynomial in form of dy by dx. I think it is sufficient to remember. If we want to find out degree of any differential equation, we have to remember that our differential equation must be a polynomial in form of dy by dx.
Okay.
Maybe
Write-
highest order
write
derivative.
down another example.
So in this case, if you try to just separate this, which is not possible. So degree will not be defined. If possible, to separate dy by this, we try to separate. But if we separate this, then this will be under some log function. So this will not be a polynomial. So in this case, degree is not defined, but order is defined. So yes, you want to give another example?
Yes. Sine.
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 Yes.
Due to y over dx square.
Sine
Due to y over dx square
I dx square
equal to
is equal to
dy over dx का whole square
dy by dx का
whole square
whole square
plus dy over dx
plus dy by
dx
dx
plus y.
plus y.
What is the degree of this differential equation?
Yes.
This is a polynomial dy over dx जो कि तो अभी बोल रहे थे.
Yes, but here sine this is not a polynomial because this is inside the
तो
sine.
अभी बोले कि dy over dx
हाँ.
में polynomial
And
होना चाहिए.
any another highest order derivative. So if I say that if you take
तो
this
तुम
one,
आधा हर बार आधा अधूरा डेफिनेशन क्यों बोल रहे हो?
नहीं. If dy by dx are any highest order derivative inside any function which is
ये
not
बोलो ना any derivative of y.
any derivative of the y, yes. So in this case, if you try to separate this one, then this will be sine inverse something. This also will not be polynomial. So in this case, degree is not defined. We have to remember that any other order derivative must not be inside the sine or log
Sine or
or
log.
any trigonometric function. For example, I am going to take one good example. If you are want to take that sine dy by dx is equal to x plus y. If you just observe this differential equation closely, you will get to know that dy by dx can be written is dy by dx is equal to sine inverse x plus y. So here degree will be defined and degree will be 1 because sine inverse x plus y. That's because in that case we separated dy by dx from the sine function. So this is very confusing questions, and I think this can work as a counter example. So I think if we remember this type of things, then definitely this will help us to solve some good questions in the exam.
No, it's
And that is
teaching good,
really
like-
good. So let's discuss.
I don't know the subject, but it's okay. You're
Yeah.
teaching good, like.
Yeah.
अभी
Yes, नहीं. Yes,
चलो अभी
आज
डिग्री
में-
ऑर्डर हो गया, मतलब डिफरेंशियल इक्वेशन का टाइप्स बताओ.
Yes, differential equations type. I think we should also discuss about the type of differential equation. But
What is exact differential equation?
वो एग्जैक्ट आई थिंक यार एग्जैक्ट वाला बेसी में आएगा यार वो भी आता है dx y मैनिपुलेट करके इस सब टर्म अंदर आ जाए वो भी आती है मुझे लगता है आप क्या करना पड़ना चाहिए
What is homogeneous differential?
यस होमोजेनियस डिफरेंशियल इक्वेशन
What is the definition of homogeneous function?
yes I'm telling you what is the definition of the homogeneous function. Let's define first that any function is given f x y and what we have to do to check the homogeneous function we have to put lambda x and lambda y in place of x and y in that function. If we are able to just like lambda x comma lambda y and we can get success to write down that equation in this form, it means that is the homogeneous equation. And if you talk about the difference homogeneous differential equation,
What
at
is
that
the
time
n?
at that time we will take the and you can say that just order means like degree I would say. For example, if I am going to write x comma y is equal to x square y plus x y square. Here n will be 2 plus 1 3 2 plus 1 is equal to 3. So this is the n. And we have to put the
This is a homogeneous function of degree 3.
degree 3. Okay. Yes. Yeah, you can check like this. You can put the lambda x, lambda y. So lambda q will get lambda q will get outside. So yeah, this will be the homogeneous function of degree 3. When we are going to discuss all these things for homogeneous differential equation, at that time this step will be replaced by dy by dx. So I think I think we will discuss all these things when we solve the differential equation. Actually, there are three methods of solving differential equation in our book. First method is that variable separation. In variable separation, we just try to write down all the terms of x inside of dx and all terms of y inside of dy and try to integrate that. So this is simple formula that we have to remember. And another thing is that linear differential equation. Any
Can we write on it?
variable separation.
Yes.
Yes, you can take example. For example, variable separation. This is also a method of solving differential equation. For example, if you are writing dy by dx is equal to, you can take
F of
1
x.
plus, yes, 10
F of x comma y.
f of x,
Comma y.
comma,
x के अंदर लिखो ना उसके फिर चलते हैं
f of x, comma y.
हाँ integrate this one solution this is a homo variable separable form
Okay.
तो इसका solution find out करो इसका solution किस फॉर्म में आएगा
Solution of differential of this function differential equation. Actually, here in this case, this is a function of both x and y.
yes.
So, do you not think that it is difficult for me to separate x and y here? I think if you take something in place of function, then this will be easy for me to solve. If you take fxy, then this will be difficult for me to write down this one x form in y form because x and y both are
equal to लिखो
equal to yes
h of x
h of x
into
into
g of y
g of y.
yes
Yes.
क्योंकि this is a
Now we are
separable
yes.
तो उसको करो पूरा
Now you are
मैं यही तो पूछ रहा हूँ तुम लिख ही नहीं पा रहे
oh I could not listen to you. Yes, yeah. If you can write down any function in this form hx and gy, then it is very easy to solve because now in this case we can separate these two things. So how we have to separate? We have to remember that any terms which involve x must be inside of dx, and any terms which involve y must be inside of dy. So you can write down dy by gy is equal to hx